Good morning, everyone. I don't know whether you students are up. It's 11 a.m., but I have been up and going for hours. All right, so here you go. I am going to go over 11.4 and 11.5, and I'm hoping that y'all remember um, a figure in my classroom that I have, and it's kind of clear. It's old, and it looked like this. And I used to have this, well, I still do, but it's in the classroom. I should have brought it home. That would have been a great idea. Anyways, it has a cone that fits inside of this cup looking figure. Anybody remember that? We actually took a little field trip and went to the water fountain, and we asked ourselves, how many of these did it take to fill this up? And if you remember, it took 3 of these to fill this whole thing up. And that's where they get their volume formula of 1/3 base times the height. Okay, so basically they're saying how tall this is. Okay, so that being the height. Okay, and they're using this as the base. So you figure out whatever the area of that base is. In this particular thing, mine was a cone. All right, but you also have pyramids, which if you look on this in your book, this is what your book looks similar like. I'm sorry, it's super blurry. I don't know if I can make it non-blurry. Probably not. Anyways, it shows you here is a prism. It's a triangular based prism, and you could fit 3 of those gray pyramids inside of that, and hence the definition or the formula that we have 1/3 base times height. All right. So in the formula for the cone, you're going to also think in terms of 1/3, but your base is always going to be a circle for a cone. So it's going to be pi r squared times your height of your cone. Okay, so those are the 2 formulas. And even if it's dragged off to the side, like on your homework on page 477, like number 3, you have your circle and you have your height, and it's off to the side and it's 35, you're going to deal with it that way. Okay. I'm going to work one of these for you. Let's see. We'll just take a very simple one of the first one. I realize that you are looking in the back of the books to check your answers. But one thing that I am noticing is some of y'all are getting all of the odds right and no work, and all of the evens wrong and obviously no work, because what you're doing is you're just looking in the back of the book for the odds. So from now on, if you are looking in the back of the book and you're just doing the answer and your work doesn't match up with the answer, it's unfortunately going to be marked wrong, because you know me better than that, right? Okay, so don't do that. You can use the odds to help you get there. I expect you to use the back of your book for that reason, but you need to make sure that you're not just copying the answers down. Okay, so in on number 1, you have this as your base. Okay, and it basically shows this as 6, and therefore you would see that that's going down the center, so you would know that this is 6 also. Okay, so you can work from there and know that we have a square on bottom, so we would deal with 1/3, and it's going to be 12 squared and times your 14. And I'm going to just show you, this is the long way. Y'all have a calculator, but I am doing this so that you could do it without a calculator. Okay, all of these would be over 1. This would be 4. Okay, and then you would just take your 4 times 12, which is 48, and multiply it by 14, and you would just do the work. I'm going to continue and stop talking. All right. So then you did all your work, which hopefully you do it on the calculator. I do not expect you to do this by hand. Okay. But I canceled here. So any of this can be done by hand. Okay. And so you ended up with what the back of the book says, but this is how you go about doing that. All right. On number 4 and number 6 and even number 2, I would suggest that you flip back in your book to an example. You used a lot of these. Let's see. Sorry about this. Okay. Right here where you had this. This is on page, because you can't see it at all. It's page 467. Okay. And remember, they're dealing with apothegms. And with that apothegm, they pulled out the figure right here. Okay. I'm going to actually work one just so that you can see that worked from my angle. I'm going to put it on a different video, but I will go ahead and work an apothegm one for you. I'm going to continue going on to 11.5, and then I'll come back to the one on the apothegm. I want to give it a separate video. All right. So if you could go over to 11.5, we're going, you hopefully have already written down the formulas that I've asked you to write down. I believe they're all on page 484. Refer to your lesson plans. I work really long and hard on those to make sure that you have all the details written out and what I expect of you. Okay. But this is a pretty fantastic formula that you did not have to derive. I'm sure if you looked at it, I'm pretty sure they derived it for you, and you could actually use your brain and figure it out. But we had very smart people come before us, and I love that they were smart. But this is the volume for a sphere, okay? And a sphere, you know, kind of like looks like a basketball. I don't know why I did that dotted, okay? And then it goes around like this, okay? And your radius is here, right? Okay, so this is a fantastic formula for you. And it's actually pretty easy once you figure out what the radius is. Okay, so in your book on 484, if you look at that sphere, that is the diameter of 10. So you cut that in half to figure out what the radius is, and you can see that worked out beside it. Also, they have all of these volume formulas, and they're pretty fantastic. But I want to clarify some things on the tetrahedron. Okay, it looks like that E is on the bottom. It is not. Okay, it is really out to the side. One of the bad things about font and computers is not always can it be on the exact spot that it needs to be. Okay, the volume of a cube, they have written down as E cubed, and that is just an edge. So if you had a cube like this, okay, you need to know this is your E, this length right down there, okay? And with a cube, your sides are all going to be the same, all right? Okay, the next one, the octahedron, which means 8, and tetrahedron is 4, but it is it's a different shape than the cube, and you might have to look up what a tetrahedron is. I wish I had my phone in front of me. I could look it up and show you what it does look like. And octahedron, you're dealing with 8, and remember, all of these are called regular polyhedrons. So you're dealing with things that have equal sides, okay, in the original base. So this is what that formula is, and that E is also to the side. If you're confused and you're like, oh, I'd rather have it on top, you remember on top, it's the same. Just do not put it inside that radical with that 2. So that's why, I don't know. I don't even know if this is mathematically correct, but whenever I was in school, I just decided that in order to end the radical, I just bring it down. So it's not a 1, it's just my own formation of knowing where it ended. So I don't bring it down all the way. It's kind of like this. Okay. And that's just my own notation. I think I made it up. So I apologize if it's, doesn't even exist in the mathematical world. But that's an octahedron. A dodecahedron, you're dealing with a 12-sided polyhedron. And an icosahedron is the 20-sided figure. All right. And so I'm going to look at number 7 with you, and we're going to work number 7. I know it's an odd, but it's one of those things that if you are working the formula of a dodecahedron, you might get a little bit confuzzled. Yes, that is a word in the Karen Bull dictionary. Okay, so, and in this case, in the dodecahedron on number 7, the edge is 3, and that is all of this 3 cubed, right? Okay, sorry. So if you have 3 3s up here and you have a 3 on bottom, I can actually cancel that 3 and make this that. Okay, because if you notice in the formula, there actually was a parentheses around that whole thing. It really was just on top. No, it looks like it's on bottom too. It doesn't matter because that's how it's going to end up. It's this 3 cubed multiplied by that whole thing. Okay, so now it is 3 squared multiplied by that whole thing. And because, lovely calculator would help, but this is what we're going to do if we don't have a calculator handy. So we have this. Okay, so this is 135. Remember, what we're doing is distributing. Okay, so we have 135 for 9. Don't forget that was a squared. 9 times 15 is 135. Then we come over here and we multiply 3 times 7 times the square root of 5, which ends up being 21 square root of 5. Okay, and that is, I hope you caught my mistake. It's not 21. It is 63. Okay, 21 would be if it was just 3. I just said that too. It's 3 squared. So if you want to over here, instead of doing that, so you don't forget it, make it a 9 already. Okay, so that would be your end answer, except hopefully you caught this, that this is millimeters cubed. You can leave it like this as your answer, or you can put it in your calculator and you'll get something like 275.9 millimeters cubed. But personally, I would just keep it like this. Okay. On number 10, 10 is a very similar thing where you're dealing with that funky formula right there. I will go ahead and work number 10 to kind of help some of you who are watching the video, and those of you who are not watching the video, unfortunately, you will not get the benefit of having it all worked out, right? Okay, so number 10 is an icosahedron, and I'm going to put my formula. We have 15. One of the things that I like to see in your work is the formula written, and even if that means you have written it and then erased the E and placed, hopefully you can read that. This is a 5, okay? When you put the E over here as E cubed, now in this case, it's 6 cubed, right? Okay, now on this, I think that what we're going to deal with here is, it would help to have a calculator handy, but on this, because that 12 is on the bottom, I want to break it up and somewhat divide it. But that's not really helping me out. Let me think through this. So this is what I'm going to do. I'm going to break it down to even farther than just 12. So 12 is broken down to 2 and 6, right? Okay. And 6 to the 3rd power, you're going to have to follow me, Okay, like that, right? Okay, so I'm going to cancel this with this 6. Okay, I still have that 2, right? I'm going to cancel that 2 with this. What? So then I have 3 times 6. I have 18, which I'm not too excited about doing this multiplied by that. But because I have the answer, I'm just going to tell you what it would end up being. The 15 times 18, this is like my automatic calculator. You would get 270, okay, plus, and then don't forget, when you're distributing this 18 right here, you had to multiply it by the 15. That's where I got the, sorry, 270 down here. And then 18 times 5 is going to give you 90. And don't forget the square root of 5. And don't forget your unit. So we're going to use our unit here. Okay. And this would be your final answer. Okay. Now, if you did this on your calculator, you could go because if you did it on your calculator, you probably get a decimal, but I'll say this. If you do it on your calculator and you don't show any work and you get something wrong, then unfortunately it's all wrong. So please either piecemeal it, like show me, hey, what did you get here when you multiplied, or what did you get on this step? The more that you can show me, especially with this distance learning thing, is to your benefit, because unfortunately I'm starting to count off full points for if I don't see any work or such like that. All right, so I'm going to do another video so that we don't have super long videos on the apothem. Okay, so that will be up next. All right, thank you. Y'all have